Hello everyone, welcome to another repair video. Today we're going to be working on this Xbox One S, which has been sent in by a viewer. This particular console has been sent in because it has HDMI trace damage. So what that means is that the viewer has attempted to replace the HDMI port, put a little bit too much pressure on it and torn the traces off the motherboard. Now this is his own console, it was a home attempt, which is absolutely fine, but he sent it in just to try and get the HDMI traces repaired. From what I've seen by the pictures, there's only four or five traces missing, so it shouldn't be too bad of a job to do. But that being said, it's still going to be a tricky job to do because we've got to run very fine trace wires. So I'm not going to attempt to turn this on because there's no HDMI port in the back of it anyway. So we can attempt to turn it on just to verify that it does indeed turn on. But other than that, we're not going to be able to do any more testing. So that's all we're going to do for now. So as you can see, it does turn on, and by the look of it, it does stay on, which is absolutely fine. So what we're going to do is take it apart, see what we're dealing with, because a picture can never do justification for the damage on the inside. So we'll take it apart, take a look inside, and then we'll see what we're dealing with. And there we go. So a little bit of a magic trick there, and this console is ready to go. So taking a look then, we have a few missing traces. I believe there are 5 in total, so we take a look just there. We do have some header damage there, so that's absolutely fine. We should be able to get that sorted. One other thing I've noticed is there's a capacitor here which looks like it's been knocked off and needs to be straightened out, so I'll try and straighten that out with some flux and get the solder looking nice on that again. Fingers crossed, we'll see what we can do, and hopefully this thing will work again. Looks like there's been a lot of heat around here, but that shouldn't matter too much because the HDMI header itself doesn't contain any sensitive components. It's only when you start using heat around this area directly, so the retimer, and also the ESD-IC as well. So fingers crossed it hasn't caused any damage to that. And it looks like we do have a few scratch marks here where the clamp has been removed before, but that's just a ground, so that shouldn't be an issue. Alright, okay, so let's pop this under the microscope then, and we'll take a look at what we're dealing with, shall we? Alright, so that's not that bad. We've got a few missing traces here. So we've got a ground pad, which is the second from the left. The first pad goes to an EMI filter, so this pad here. This one goes to the first point on this EMI filter. You can trace down here and follow it along, and that goes to there. And then this one here is just a ground, so that's not really necessary. We can restore it anyway, but it's not really necessary to get the console working. This one here goes to the end of the EMI filter. And if we zoom in, we can see a little bit clearer on these. This one here goes down here to this wire here, and then to here. Or is it? Yeah, this one here. So it goes to this resistor here. And this one here is just a ground. So this is pin number 17. This is a ground. So that's not a big deal. And then that is it. So the one thing that is a little bit concerning is the fact that I see quite a lot of stuff going on here. I'm not sure just how much heat has been put on this little chip here, but this is the ESD protection IC. So that's something to take into consideration when we've restored the traces on whether or not it's going to work. Because if it doesn't work, then it could either be this ESD IC or it could be the HDMI retimer. So this is the retimer. This is responsible for taking the audio and video signals and synchronizing them before they go out to the HDMI circuit. So they come from the GPU. You could follow them traces around to the GPU. And actually you can't, because they go through wires and then they go through to the other side of the board. But they do go to the GPU, and then they go off to the EMI filters. These are passive filters, so the console would work if these were missing. But then once they come from the filters, it will go to the HDMI port itself. So that's pretty much how the circuit is, and that's pretty much what the retimer and things do. This ESD IC is electrostatic discharge, and basically this is just a protection IC. So sometimes this can blow if you get, for example, a power surge down through the HDMI circuit. But most likely, if this is faulty, it's going to be because of heat and causing problems with the BGA underneath. I can replace that if needed. I do have some of those chips, so we can buy them for the Xbox One S, but not for the Xbox One X. So that can be replaced if needed. So that's not too much of a problem, but it does of course add to any costs and things like that when we're considering the quote for the repair. So that's going to be of interest if it doesn't work. But for now, what we're going to do is just drop a HDMI port on here and then run some jumper wires. First of all, what I want to do is just clean up the area. So I'm going to put some heat into the board, which sounds a little bit counterproductive, but the flux that's on there, I want to clean it away. With how long the flux has been there, it's going to be dry and sticky, and it's not going to clean away very easily. So I'll just put some heat in the board just to clean it up a little bit. I'm going to focus a little bit of attention on this area here as well. So you'll notice I didn't get it hot enough to actually melt the solder. All I wanted to do was just warm up the flux, just so we can clean it off. So now what I'm going to do is take a toothbrush and some isopropyl alcohol and just give the area a nice good scrub. Just get rid of any leftover flux and make the area look a little bit cleaner. It's going to be a lot easier to work with if the area is clean. So just give it a really nice scrub. And then while the hot air is cooling down, we're going to dry off the isopropyl alcohol. And now we're ready to start working on the board. So the first thing I'm going to do is take off the EMI filters, because I need to run a jumper wire to the EMI filters themselves. I could run the jumper wire to the trace, but it's going to be a little bit difficult to get a decent connection on that, so I'm not going to do that. I'm just going to take the EMI filter off temporarily, solder the jumper wire from the top to the bottom, and then drop the EMI filter back on. So that's going to be the plan. So we're going to use some hot air and remove this EMI filter here, or rather both of the EMI filters. So my hot air is set to 440 degrees Celsius with 40% airflow. There we go. So there's one. And there's the other one. So I'm going to put those to one side where I'm going to find them later. They are fairly small. And then I'm going to take some flux. I'm going to replace the solder that's on here at the minute with some fresh leaded solder, just to lower the melting temperature and make it a little bit easier to work with the area. Okay, and you can see that this trace here, the end trace there, is actually damaged anyway. So some of the trace is there, but some of it is missing. So either way, we're going to have to run that end trace from the port to the one side of the filter, just to complete that circuit. But that's absolutely fine, that shouldn't be an issue. If you've watched any of my soldering videos, you'll know that we can indeed run jumper wires underneath a QFN chip. And the EMI filters are pretty much a QFN chip on these, so it's going to be the same scenario. Okay, so with that out of the way, let's move on to this part just here, and I'm going to do the same here. I'm going to re-tin these and just replace the solder. There's a little bit of dirt and grime there, so I'm going to replace the solder and then I'm going to wick it away just to clean those pads and give us a nice fresh working area. I'm just going to go around in a circle. There we go. And now I'm going to wick away using Goot Wick. Goot Wick is fairly cheap. I buy mine from eBay. Some countries can't get it, so unfortunately I'm not sure where you will get it from if it's not available in your country on eBay. You could try AliExpress, but I'm not 100% sure if they'll ship to your country. I buy mine from eBay. It costs around about £2.50 or something like that, delivered for 1.5 metres. So it's fairly cheap and it lasts quite a while. And then as you can see there, we've got a nice fresh canvas to work with. Okay, the next step that I'm going to do is just drop a new port onto the board. And I'm hanging the motherboard over the edge of the table just to be able to do this. And then I'm going to heat up the area and just drop a port on. So I'll try and use OEM ports wherever possible. So what I'll do is I'll take the HDMI input port off a donor board, and the reason for that is just because they are OEM spec, and these ports are a lot stronger than people actually think. So I'll take the HDMI input port. I'll never use the HDMI output port because that gets used quite a lot, but the input ports, no one ever really uses them, and they're generally pretty much brand new. So just take the port, okay, so what I'm doing now is just dropping the new HDMI port onto the motherboard and just basically using hot air to solder it into place. Now let's flip the board upside down, and what I'm going to do first is just clean this area off because there's a lot of heat been on this area and a lot of flux. So while the board is warm, I'm just going to clean it off using isopropyl alcohol and a toothbrush. Just get it nice and clean and ready to accept some fresh solder. And then I'm going to secure the port in place. Just dry it off there quickly. And then just secure it in place with the soldering iron. So we'll add a bit of flux there to each of these ground legs. And then just add some solder to the pads. Just make sure we've got a nice amount of solder there on each of them legs. There we go. Alright, let's use some isopropyl alcohol and the toothbrush again. Let's clean up this area. We're done with the back for now. But we just want to inspect them joints, make sure that they're all nice and shiny. And that looks good. That looks pretty good. Okay, I'm happy with that. Alright, so let's just try and straighten this out. Alright, so let's press and hold there. That's set. Let's pop it back up. Let's pop it back under the scope. And that's sitting much better. Much better indeed. Alright, brilliant. Okay, so we've got 5 missing pads then. So let's start running some jumper wires now. So what I'm going to be using for this is enamelled wire out of a microwave fan. So this is the stuff right here, and it's absolutely perfect for running HDMI trace wires, and it works absolutely brilliantly for me. So what I'm going to do is just add a little bit of flux just around here, and I'm going to start from the right and come to the left because I'm left-handed, and it's kind of like writing on a chalkboard. If you're left-handed and you start writing on a chalkboard, your palm will rub it out. It's the same for the HDMI traces. If we are left-handed, then we want to start from the right because we don't want to end up knocking the wires as we're going along. So let's just tin the end of the jumper wire. There we go. We're going to start with pin number 17. And tack that roughly in place, and then we're going to use the tweezers to guide it properly. So we want to guide it a little bit more precisely, so we just use the tweezers for that. Even though it is actually soldered. There we go. Okay, so you can see I've run a very small jumper wire there from pin number 17 to the pad, but that's not going to be connected to ground because there's nothing to connect it to ground. So I'm going to bring the wire just over here a little bit to this point here. And just solder it to there instead. So by soldering it to there instead, we're using the ground from the rest of the port. Whoops, that's come off. Okay. And then I'm just going to put a little bit of solder here. There we go. So now let's just adjust this wire. Okay, that doesn't quite reach, so I'm going to have to move it. There we go. So there's pin number 17, which is the ground wire. So I'm going to clean that up and then basically just make sure that we don't have any shorts on the pins next to it. We obviously don't want to short out pin 18 and pin 19 because they're not meant to be ground connections. So we want to make sure now, before we go any further, that they're not going to short out, and then we can secure it down with some conformal coating and make 100% sure it's never going to short out. So let's just dry that off with some hot air. And then I'll soak it up with a cotton swab as well, just to make sure. If we're going to be adding some solder mask to it to secure it down and protect the area, we want to make 100% sure that the area is clean, so as the solder mask sticks to the board properly. Alright, there we go. So let's just adjust that wire. It doesn't matter if the wire crosses here because the enamel coating is still there, so that's absolutely fine. It's where the wire has been exposed that we don't want this to cross. So what we want to do is just use the multimeter in continuity mode. And continuity mode is the mode that's going to beep when we complete the circuit. So if we pop one probe on the top of this port here and one probe on this part here, you can see we've got a continuous path, and that is now a ground point. So if we check pin number 17, we have a continuous path to ground. Pin number 16 we don't. Pin number 18 we don't. And pin number 19. Excellent. So that's not going to short out to ground on the other pins, which is what we need, because those pins are not meant to be a ground. They're meant to be running to other parts of the board. In this case, they're going to run to the resistors, and from the resistors they're going to run to the ESD IC. So if we was to short that out to ground, chances are it's going to burn the chip out and cause us all sorts of problems. So we want to make sure that doesn't happen before we go any further. So what I'm going to do now is I'm going to run a very short jumper wire from pin number 16. And the reason I'm going to run a very short one is because we don't need anything else apart from a short wire, because as you can see the trace has broke off, but it's very close to the pin. So what I'm going to do is I'm just going to use a little bit of flux. And then I'm just going to pre-tin the jumper wire just by running the soldering iron over it. So the enamel coating will burn off with the soldering iron. And then all I'm going to do is just run a jumper wire from the pin itself. I'll actually do a little bit more just so we've got a little bit more room to work with. So let's expose a little bit more here. So we're going to run it from the pin itself to the trace. So the trace should be fairly easy to run a jumper wire to. Okay, so we've got that initial bond on the trace itself. So now we can use the tweezers and hold the jumper wire with the tweezers while we solder it to the pin. There we go. Okay, so now we can just chop this jumper wire at the end. And that should be good. It's secured there, it's secured onto the trace, and it should be good to go. So let's go to the next one, which is this one here. And this one here is going down to the EMI filter. So this one we do have to run a jumper wire all the way down because the EMI filter is broken just at the bottom here. So we're going to have to run a jumper wire all the way down for that one. We could rejoin the connection at the bottom and then run the jumper wire to the top, but it's kind of pointless. We may as well just do it in one long run. So let's just tin the end there. So once it's roughly tacked in place, just enough to hold it there, we can grab it again with the tweezers and position it properly. And then come in with a swoop of the iron. Solid. So once we've done that, I'm just going to flatten it to the board. And what I'm going to do is just add a bit of flux down the bottom, just here. And I'm going to tin it and secure it onto the rest of the pad. So I'm going to add a little bit of excess so I can shape the wire afterwards. There we go. And then just break away the excess once again. Just like that. So let's zoom out a little bit so I can just shape this wire properly. I'm going to try and follow the original path. That's just come off at the end. Damn it. Never mind. Hold that in position. And there we go. Alright, let's just give that a clean. So I'm going to heat it up with some hot air. It's getting a little bit tricky to see around here now. I'll just gently scrub away with the isopropyl alcohol and the toothbrush just to get rid of all of that burnt flux. And while it's doing that, it's also flattening that wire down to the board. We are going to secure that wire because we can't use hot air for too long around that before it comes loose. So we will secure that wire before we drop that EMI filter back on. Let's just dry that off. Just take a look, and that looks fine. Okay, so just these two end ones to do then. So we've got one ground and then we've got the other EMI filter. Once again, we're going to add some flux. And what I'm going to do, because I'm going to need to find somewhere to route that to, so what I'm going to do is I'm just going to cut the end of it away, leaving a fair amount of jumper wire there. Cut the end of it away and then just leave it loose for the time being, just until I've run the other jumper wire. And like I said, the reason for that is because I'm going to need to find somewhere to secure it to. So if I just basically leave a fair bit of excess here. So I'll just leave a bit of excess there, just leave it dangling. And I'll probably end up securing it to that middle pad, because that middle pad there is a ground pad. So that's probably where I'll end up securing it to, but I haven't quite decided that yet. Finally, before I can call this job done, I need to put them EMI filters back. But before I can do that, I need to make sure the board's nice and clean and add a little bit of conformal coating to the area just to basically glue those wires in place. Okay, I'm going to get some conformal coating. So the conformal coating that I use is made by Mechanic, and it's basically a UV glue. So what that means is that when we apply a UV light or something on the 405 nanometer wavelength, the UV mask will basically cure itself, harden and secure the jumper wires in place. And we really don't need a lot. You can get this in various colours. I'm going to be using the red today just because I feel like a change. Doesn't really matter, but apparently some of the colours will make a difference to how they adhere to the motherboard. But what I'm going to do is just add a bunch of UV mask there with the tweezers, and basically just glue them down. And the reason for this is because we need to, number one, make sure that they don't come loose over time, and number two, we want to be able to use hot air on the area, and the only way to do that with a jumper wire is by using UV mask, or at least securing it so as it doesn't come loose. So we use UV mask and it basically glues them down in place. I'm also going to protect this area just here, and the thicker the layer as well, the longer it's going to take to cure. So we don't want much, we just want a little bit on the board and a little bit on the wire just to bond together and basically bond the wires to the board. Really don't need a lot, to be honest. We just secure that wire down, make sure it doesn't come up when we use hot air. So what I'm going to do now is I'm going to use a 405 nanometer wavelength laser, and that's going to cure it in around about 20 to 30 seconds. So I will give you a warning: if you are suffering with epilepsy, please look away now. Do not look directly into this light because I don't want to be responsible for any kind of seizures. So if you are an epileptic person, then please just look away. I'm going to use this light now in 3, 2, 1. And that should be nicely cured, so it's safe to look back now. Let's just take a look. Let's just test it with the tweezers, and as you can see, nice and solid all the way along. Okay, that's good. So what we're going to do now is just double check and make sure that now we've secured it in place, it's not going to short out to ground on those pins where we've soldered a ground wire and extra wires as well. So we're going to do the same thing again. We're going to do a continuity test on the pins, make sure that we don't have any shorts to ground where there shouldn't be, and make sure that there are shorts to ground where there should be. So if we zoom in here, we'll put one probe on ground. In this case, I'll use the ground point just at the edge here, and we'll test pin number 18. Pin number 18 is good, that's not shorted to ground. Pin number 19 is not shorted to ground. The reason I check them two is because this one is crossing. Pin number 17 is ground, that's fine. Pin number 16 isn't ground, that's absolutely fine. So pin number 16, as you can see, has got continuity to the bottom of the trace. Let's take a look and follow it along and make sure that we have continuity where it's meant to have it. So it's going to be R8B2 for pin number 16. And as you can see, follow it along and we get continuity. That's good. So this pin here that goes to the filter also has continuity to the bottom of the trace, and it doesn't have continuity to the one next to it. And it doesn't have continuity to the one on the right hand side either, which is perfect. So pin number 2 is a ground, and as you can see, that's a ground on the middle. We don't have a short to ground on the pins. Whoops, I realised you couldn't see that. So that's ground there, that's ground there, and then ground at the top, which is perfect. So pin number 1 is the final one to test, and that's got a continuity to the bottom pad. As I said, these are passive filters, so the trace is complete from the top to the bottom, and that one is now complete, so we've got a jumper wire in place for that. We don't have any shorts to ground on pins 1, 2, 4 and 5, which is good. So now we're ready to drop the EMI filters back onto the board and basically complete the rest of the circuit. So like I said, these filters are not actually needed for the circuit to be complete, but we still want them there to do their job. And believe it or not, there is a certain way that these are meant to go as well. So I'll show you that now. So as you can see here, we've got the pads for the EMI filters, and we've also got a dot just here. And that dot is going to line up with the EMI filter. So if we take a look at the EMI filter, there's a line on the filter, and that's going to line up with the dot just here for it to be in the correct orientation. I'm not sure if it makes a difference. I'm not going to pretend I do. All I'm going to say is that it's got a dot there for a reason, and we're going to line it up exactly how it was. So what we're going to do is just add a little bit of flux to the area, and then I'm going to drop my hot air back down to 20%, and then I'm going to use the hot air just to flow this filter into place. I'm going to press very gently because these are very fragile. Okay, and for the next one, let's just try and figure out which way this is meant to go. It's a little bit burnt up, so I'll just use a bit of isopropyl alcohol and a cotton swab and just give it a little bit of a clean, just so I can see where it's meant to go, or the orientation. I don't think it will make much of a difference, but we're going to put it back how it's meant to be anyway. I'm just going to scrub that. And that's not coming clean to a point where I can see that line. I believe the line is here. Because I can't see it on the other side. And yeah, I can see it now. Okay, yeah, I can see it now, so that's fine. So let's add a bit more flux. Just to this point just here. And then I'm going to press down. Whoops. I don't mind it being a little bit lower, just so as it sits properly. It would normally sit properly with the trace there, but the thing is the trace is actually still there at that point, so we want to make 100% sure that it's going to sit properly on the pad. And we'll do the same for this one as well, actually. There we go. And then what I can do is just come back in with the soldering iron and touch up those pads, make sure that they're all nicely soldered and that we've got a nice connection on all of them. There we go. So let's clean up. And that should be good to go. So what I'm going to do is I'm just going to make 100% sure that we have continuity. Just by double checking again. It doesn't hurt to check one more time just to make sure. So let's just use the multimeter once more, and we're going to check from top to bottom. We don't have a short on the one next to it or to ground, which is good. And that's good as well. This one here is good. Excellent. So as you can see, by putting a little bit of conformal coat in there, or solder mask, whatever you want to call it, we were able to solder the EMI filters back on without the jumper wire moving out of where it was meant to go. So we basically glue the wire down there just to make sure that it stays in place. And one thing that I am a little bit concerned about is the amount of heat that was used on the HDMI encoder, but we'll deal with that if it doesn't display or if we have any display issues. And also obviously the ESD protection IC as well, so that's a little bit of a concern, but if it needs it we can always replace them. So before I do anything else, I just want to focus my attention on this capacitor just here. Basically just clean this up because it looks a bit of a mess. I'm just going to focus a tiny bit of attention just here. All I'm going to do is just use the soldering iron on its own just to clean up this capacitor. Just get a nice connection there with nice even joints. So I'm just going to smooth off these pads on the cap and on the board itself. Let's replace the solder that's there actually. So just a little bit of extra care and attention for the customer. I do remember the customer contacting me about that one capacitor, and I don't believe it's actually needed, to be honest, but it's there, so I'll straighten it up. And we're good for testing. And just for the record, I have cleaned the APU side off because I kept doing that. So let's flip this around, and I'm going to straighten these out again because I used some hot air on it earlier as well, so I'm going to straighten those ground legs out just to make sure it's nice and secure in a minute. I just want to put the heatsink clamp back on. There we go. So with the heatsink clamp on, I'm going to use the soldering iron. And just straighten these out. There we go. Some nice even joints. And that's how it should look. minus the burn marks. But that wasn't me. Okay, so let's get the components installed so we can give it a test. I'm going to test it outside the case. Okay, so we'll test it outside the case, because if it doesn't work, then it saves us having to disassemble it once again. So if there's any reason why it doesn't work, then we can just get straight back into it. So we don't put it back together before we give it a test. Here we go. So let's pop it onto the capture card then. There we go. Yes. We have a display. That's fantastic. That's absolutely brilliant. Right, let's get a controller. I'm going to plug the cable into the front port. And the controller turns on, which is great news. And there we go. So this is displaying. So let's just check in the settings and make sure that it's displaying in 1080p. And it is indeed. So let's switch between 1080 and 720. There we go. And then back to 1080p. Takes a couple of seconds just for the capture card to pick it up, and there we go. So that works absolutely fine. So that is pretty much it. So all that's left to do now is just to put it back together. I'll do that off camera, but for the sake of this video, this job is done, and this console appears to be working absolutely fine. But just to summarise, this console was sent in because it had HDMI trace damage on the HDMI header. By running a few jumper wires, 5 in total, and by soldering a new port on, I was able to get the console to display again, and this console can work again. But that's going to be it for this video. Thank you very much for watching. If you do have any comments or questions, leave them down in the comment section down below. I will always do my best to answer them. And if you want to see more repair videos where I try and fix mainly consoles, but sometimes other things too, be sure to hit that subscribe button and turn on the bell notifications so that you're notified every time that I upload. I also have channel members, so for as little as £1.99 per month you can support the channel, and all channel members get early access to most of my videos. But that's going to be it for this one. Thank you very much for watching, and until next time, see you later. Bye for now.